So you see here now on the screen, we're in one lab. I already have a username, so I will sign in right here. One important thing to notice is as soon as I'm signed in, anything I do in the OneLab software is logged under my name. Any protocol I design, any experiment I execute, any device, so robot or smart stand I use, today we will know Sophie used this on the 28th of February to do this particular experiment. So everything's traced. And before we go into the heart, meaning the designing and the execution of your experiment, this is what opens up when you open up OneLab. On the top left here, very important to note is you see now we're in the sales lab at Andrew Lines. If we click on that, you see we are about 26 members currently. If you go even a bit deeper, you can see who those members are and the associated rights for those members. You can easily invite a new member. Just enter their work email address and you will see that you can even associate a role with these members. So for example, if there's a technician joining your lab, you can provide them with operating rights, meaning they can execute certain things, but they will not be able to change things. So this is very easy. As soon as this email is sent and is accepted by your new member, they will have access to the lab in your OneLab. So in this case, the sales lab as well. This is very important to note, and this shows you there's really a user management system built in within OneLab, where you have different rights that can be associated with different users. At the heart, OneLab is really designed for two main things. The first one is designing a protocol. The second one is the execution of your experiments. A protocol is really the method you're looking to execute, while the experiment is when you take this method, you go to your lab bench and you start producing real-life results. So without further ado, what I want to do with you guys together is make a protocol from scratch. We'll run it on the Android Plus robot, and then we'll run the same one on the Smart Stand Pipet Plus as well. So we're going to be clicking on Design a Protocol. The first thing that pops up here is the virtual bench. This is your virtual laboratory bench, and OneLab will guide you. So for example, you see here, start by adding your labware. So if we click on the labware icon, you'll see here we have different categories of labware ranging from tubes, microplates, microchips, columns, and so forth. You can even filter by manufacturer and well capacity and so forth. In our example, we'll use a 50 ml Falcon tube. You can just click on Add, a 96 well plate. And you see we have many different ones here, right? So this is extremely modular, extremely customizable. We even have multi-channel reagent reservoirs when you're using the multi-channel pipettes. Click on Add. On the right there, you see all the laboratory, the library that I'll add to my bench. So I'll just click on Add to Bench. And now we have the same virtual bench, but with these three empty labwares. The next thing, as OneLab is telling me to do, is to add any buffers, reagents, samples we may have. So what I'll do is I'll click on my 50 ml Falcon tube. There's a pop-up that says, what would you like to add? I'll add for example, a buffer in this case. We have different options, fully customizable to your lab. Select the buffer, and now there's a color in this tube, meaning it's filled with a solution, in our case, the buffer. And now the fun stuff can really start. So for example, we can start pipetting from our 50 ml tube to our multi-channel reservoir. How do we do that? We click and we drag from the source to the destination. Once you do that, the next configuration pops up and OneLab is asking you, how much would you like to pipette? In this case, let's say, for example, we would like to pipette 5 milliliters or 5,000 microliters. I can say save step, and you see now on the right hand, this step is written for you already. You don't have to write this. We can now create a second step, just so to make sure everyone understands it. Click and drag from the source to the destination, your volume. So again, let's say 5 ml. And you'll notice as well, is that we have advanced pipetting parameters built in as well. So you can change between reverse pipetting, repetitive pipetting. You can You can indicate if you're using highly viscous solutions, highly volatile solutions. You can even say where the tip position should be. In this case, what I would like to do is I would like to use the same tip from step 1 in step 2. So I'm just going to say, please keep my original tip. Save step. And there you see on the right-hand side again, here, you have your second step, 5 ml from your tube to your reservoir. And this is how we can keep completing the protocol. So for example, now we can go from our reservoir, click and drag, to our microplate. What pops up is the actual microplate, and now we can indicate the columns we want to pipette into. For example, 1, 3, and 5. You can see them highlighted here in blue. You also see the wells that are selected. I can say save selection. And again, the volume is being asked. What I'll do is I'll say I want to pipette 90 microliters in each one of these wells. I can go down to advanced and I can say in this case, I would like to do repetitive pipetting. What does that mean? You pick up a big volume and you dispense smaller aliquots, in this case of 90 microliters in each well. I can click save step, and there's our third step right there. If you forgot something, if you made a mistake, no worries. You'll see here, you can just go back into the step, you can edit it, and there you can see all the different configurations. There we go. Now, this is an example protocol, but you have to know that OneLab is not just a pipetting software, pipetting protocol designer. It's really a universal protocol designer. Why is that important to note this? It can do so much more than just pipetting. On the left here, you see different actions we can incorporate. For example, we can incorporate a shaking step. We can incorporate a cooling, a heating step. Different things can be applied here that really make the protocol complete. So there we go. So now we have our protocol. This is independent of the devices that we are going to be using to execute the protocol. So now we can press on execute. You see here the execute button. And the next screen that pops up, it just shows you the various ways that we can actually execute our experiment. One of them is to do it manually. So really we did, for example, a single channel pipette, well by well, where you as a user, you have to change the volume. You really have to do everything manually. The other ones are the Andrew Plus robots and the Piper Plus smart stand. We'll do both today. So I'll start by saying I would like to do or run this protocol with Andrew Plus first. Very important here is, remember I didn't mention in the designing of my protocol to use a multi-channel. I didn't mention which tips I wanted to use. This is all done in OneLab, and here you see exactly the type of pipettes, tips, and domino blocks I'll need. I'll talk about the dominoes later when Andrew Plus is actually working, so you have an idea. But here you have a full setup of your material lists. I'll click on continue. And then the next screen that pops up is really what you have to make sure that's around Andrew to be able to successfully carry out this experiment. So this is actually a bird's eye view. So you see here the top of Andrew. We have different tips here. We have a tube, reservoir. One is red. This means that I actually have to input the volume I have in my buffer. In this case, this is the minimum volume that I need. And you'll see later on that I actually have a bit more. So I'll just update this to, I'll have 50,000. There we go. I checked it, perfect. And we're all good to go. We go back up. Now we can click on start experiment. And then you'll see, we'll actually switch the camera now to Andrew. And then you'll see Andrew Plus working in real time. So now you see we went from OneLab, and OneLab is giving the signal to Andrew Plus right here, who will start executing the protocol we just designed. Andrew Plus is really an extra companion in your lab. He's there to take over the very repetitive pipetting work, to do it without any errors, And you see he's actually a visual companion. What do I mean with that? He has a camera built in. You see the light there under his arm that's moving. And this camera is checking the whole deck around Andrew's body right now. This is crucial because remember, Andrew has to know which tips are there on the deck, how many tips are on the deck, where is my ladder, where are my domino blocks. So for example, you see here, I'll give you an example just to touch. You see there is different blocks around the Andrew Plus robot. We call them dominoes, and they all have different barcodes associated with them. And what that means is this gives Andrew Plus a really good idea of where everything's situated. And without further ado, Andrew just checked the whole lab bench. Everything's good to go. We have enough tips. We have our consumables. Everything's ready. Remember the first step we indicated in the protocol was going from a 50 ml tube, 5 ml, into a reservoir. So Andrew took the right pipette, in this case the 5 ml pipette. He's now checking, because we just started the experiment, he's checking the tip to make sure he knows the height of that tip. And then he will go to a 50 ml tube and start the pipetting action of 5 ml. Again, as Nigel mentioned, these pipettes are top-of-the-line Picus pipettes from Sartorius. They have an added capability built in, a Bluetooth capability, that allows them to communicate to the robot and in turn to one lab as well. So the volume is set to 5 ml. He's taking the buffer. He's going to a reservoir right now. In terms of speed, aspiration speed, dispensing speed, mixing speed, this can all be changed. And you will also move the liquid level to make sure that he's always taking up liquid and never air. In terms of volume, you'll see here we have various pipettes, single channel pipettes, multi-channel pipettes. The volume range is between 0.2 microliters and 10 milliliters. So it's a very wide volume range. As I mentioned, this is not just a pipetting robot. This can handle many more tools. It can move plates around, it can move tubes around, and many more things. The same for the dominoes around the deck here. You can use simple dominoes to put your ladder in, but you can also do a lot more sexy stuff. Like for example, you can include shakers, you can include heaters, coolers. They're all speaking to one lab and in return speaking to Andrew Plus as well. So here, remember now we have the buffer, we have transferred it from our 50 ml tube to our reservoir. The next step is to do a repetitive dispensing from our reservoir into our 96 well microplates. And exactly since we're using this pipette again, it's just checking to make sure all 8 tips are on the pipette and that we know where to start pipetting from. One of the benefits of Andrew Plus as well is it is very future-proof. You can start with a very simple setup in the beginning and add on your dominoes, add on your devices later on. So you see here how he's repetitively dispensing the various volumes into the microplates. All these dominoes as well, you see here, it's very modular, they're magnetic, so you can just click them to each other, change the direction. One day you can run an assay with 8 different microplates, the next day you can run 20 different tubes, fully modular, fully flexible. And he takes care here of just putting the pipette back, as he should. And now the experiment has ended. And I think here it's important, Nigel, maybe we can just switch the camera again. And here you can actually see, so Andrew Plus finished the experiment. There were no errors. It took this much time. It was done by myself, so by Sophie here. And these are the materials that we have used in this particular experiment. And step by step, what protocol steps took place, how much time it took, and so forth. If I now click on Validate Report, this is logged in time forever, meaning in 10 years, in 20 years, when you come back to one lab, you will see on the 20th of February exactly what I did today.